Yeah, hi everyone. Welcome to my Max Academy. In this video, we'll continue with Chapter 4, Quadratic Equation from 10th Standard CBSE Max. Now, we'll start with the next section, which is in page number 76, the method name, or page number 77. The method name is, we are going to solve the quadratic equation by the method of completing square. So, till last video, we were doing solving the quadratic equation by the method of factorization, and in this session we will try to find the roots of the quadratic equation or solution of the quadratic equation by the method of completing square. This is one more method wherein we can apply this method to solve and get the solution or roots of the quadratic equation. So the method name is method of completing squares. Method of completing squares. Method of completing squares. Method of completing square. Method of completing square to solve the quadratic equation. So now we will go to example 7 in your textbook in page number 80. So example 7. So page number 80 in your textbook. Page number 80 in your textbook. Now we need to, it says solve the equation given in example 3 by the method of completing square. So in example 3, the question was 2x square minus 5x plus 3. So this was the question given in example 7, which we did in our previous videos. So the same quadratic equation, I should say, equal to 0. We have to solve this. So earlier we solved using the method of factorization. Now here we should solve this using the method of completing the square. Method of completing the square. Method of completing the square. We have to solve this using method of completing square. Now to solve this using method of completing squares is, we need to be very careful with 2-3 points. The first step to apply the method of completing the square to solve this quadratic equation is, we should make sure that the coefficient of x square is 1. We can also solve by keeping this any number, but we will take or will make the coefficient of x square as 1. You should always make the coefficient of x square as 1. That is the first step. Now here it is 2. Now how do I make it as 1? Here it is 2. So divide throughout by 2. So divide by 2. Each term should be divided by 2. So this will become 2x square by 2 minus 5x by 2 plus 3 by 2 equal to 0 by 2. So everywhere you have to put by 2 by 2 by 2. Each term should be divided by 2. Because you want to make the coefficient of x square as 1. That is the first step. So then what will happen? 2 will get cancelled. You will get x square minus 5 by 2x plus 3 by 2 equal to 0 by 2 is 0. Don't put 2. I've seen people putting 0 by 2 as 2. Sometimes in a hurry, you have to be careful. 0. Even I have done many times by writing 0 by 2 as 2. So in a hurry, we may make such mistakes. So we have to be careful. So 0 by 2 is 0. Now what we have is, we have this equation now. Now we need to always, in these two equations, forget about the constant term which does not have x. Now take these two terms. Now we have to write this in the form of a plus b or a minus b the whole square form. We have to get this either in the form of a plus b the whole square or a minus b the whole square. Now what is a plus b the whole square? That is a square plus 2ab plus b square. A minus b the whole square is a square minus 2ab plus b square. So we have to get these two terms. We have to change this in this form, either in this form or in this form, so that I can write it in the form of a plus b the whole square or a minus b the whole square once I get it in one of these two forms. Now if you observe this, we have two terms like these two terms, either these two terms or these two terms. Now here it is minus. So which is more like this term. The third term is not there. Don't take this as the third term. Take only these two terms and compare these two with these two terms. Because it is minus, so I am taking this. If this was plus, I would have taken these. Now compare these two. Now your a square compare with x square. So your a is what? Your a is x. So we can write here rough work if you want. My a is x. because in a square, in the place of a square I have x square. When a square is equal to x square, my a is x. In the place of a, if I put x, I will get x square. Now next one what we have is minus 2ab. This minus is this minus. Now in the place of 2ab, I have 5 by 2x. Now we'll write that 2ab is equal to 5 by 2. 2ab equal to 2ab is equal to 5 by 2x. What is 2ab? In the place of 2ab, what I have? So this is your a square minus this is 2ab. So 2ab is what? 5 by 2x. Now we need to find the value of b from here. You need to find the value of b because a we know a is x. We should find what is b. Now for that, now substitute. 2ab is this. Now this is x. So substitute a as x here. So 2a is x into b equal to 5 by 2x. So 2ab means what? 2 into a is x, b. We need to find b. What is b? In this, we know a is x. What is b? So that my 2ab will become 5 by 2x. What should be my b? B. So that my 2ab will become 5 by 2x. Now, so we are going to find the b. So which means bring this down. So b will become, this is 5 by 2x means what? 5x by 2 by this is 2 into x. That will also come down. So it will come here. This 2x also goes to this 2. So it will be into 2x. This 2x will go to the denominator. This is 5 by 2x. And this 2x will go down. So x will get cancelled. Then your b will become 5 by 4. So what is your b? 5 by 4. This is clear how we have found b. And this is a very important point. Once you are clear on how to find b, then after this solving is easy. So first, as I said, we need to take these two terms. Don't worry about this constant number. Take these two terms and compare this with either a square plus 2ab or a square minus 2ab. But here I have minus, so it should be like this. So compare this with a square minus 2ab. If you compare this with a square minus 2ab, my a square becomes x square. So which means my a is x. When a square is equal to x square, my a will become x. Now I have found a. Next I should find b. Only if I find a and b, I can write this as a minus b the whole square. I can convert this in the form of a in these three forms, then I can get it in this form. So first step is take these two terms, compare it with these two terms, and then find a and b. Now we have found a is x and 2ab is what? 2ab is, this term looks like 5 by 2x. So your 2ab is 5 by 2x and then substitute a as x here. In the place of a put x, then solve and find b. B is 5 by 4. Now we have got b. Now this can be written as a square. This is x square. This is a square minus 2 into a. A is what? A is x into b. B is what? 5 by 4. Now if you multiply all the three, what do we get? 2 into x into 5 by 4 is what? We get back this 5 by 2. So this 5 by 2 we have written it in the form of 2ab. 5 by 2x we have written it in the form of 2ab. Right? We did not know b. That's why we had to find b like this. At this step we did not know b. So we were equating a and b and we found b. Now after finding b, we will write this as 2ab. Now I have got a square minus 2ab. I have got these two. Now next what we need plus b square. Which means, so I know b is 5 by 4. So I will put plus 5 by 4 whole square. This is b square. But I cannot just like that add something. I have to subtract that also. So I have to subtract 5 by 4 the whole square. Let's see, if you compare now, x square is x square. Now if you multiply all this, you will get this. So this x square I have written like this I have written like this. Then I am adding something extra, plus 5 by 4, plus b square I am putting, b is 5 by 4. I am putting b square to get it in this form. So, but just like that I cannot add something to an equation. Right? I have to subtract the same quantity that I am adding. Only then I can say this step is equal to this step. Now if you cancel, these two will go. This is plus 5 by 4 whole square minus 5 by 4, these two will go. If I multiply, I will get these two. Then find what is finally left out, 3 by 2. That I will write here, plus 3 by 2 equal to 0. Right? See, this x square is this, and this is written in this form, and this 3 by 2 is this, But in between what I have done, I have added a quantity and subtracted the same quantity. Or added b square, subtracted b square. Always we'll do plus b square minus b square. Now if you simplify this, you'll get back this. So the same thing is written in this form. But what is the advantage of writing in this form? I can write this whole thing as what? This whole thing can be written as, this looks like a square minus 2ab plus b square. What is a square minus 2ab plus b square? Can be written as a minus b the whole square. This entire thing can be written as a minus b the whole square. Clear? Then what do we have next here? Minus 5 by 4 the whole square. 5 square is 25. 4 square is 16. Plus 3 by 2 equal to 0. Any guys clear till now? Fine. Any doubt? Right. So we need to find a and b by equating this with this. If this was plus 5 by 2x, we would have equated with this. In that case, we would get x plus 5 by 4 the whole square. It will become a plus b the whole square. So this entire value, this instead of these three terms, this is like a square minus 2ab plus b square. I am writing it as a minus b the whole square. Then minus 5 by 4 the whole square means 5 square is 25. 4 square is 16. This I am writing as it is. This writing as it is. 3 by 2 is 3 by 2. Now again x minus 5 the whole square equal to, now move these numbers to the other side. So minus 25 by 16 will become plus 25 by 16. Plus 3 by 2, if it goes this side, it will become minus 3 by 2. Now keep x alone here. I mean a minus b the whole square alone here. So this will become x minus 5 by 2 the whole square. Sorry, 5 by 4 the whole square. Now do the fraction subtraction. So LCM is 16. So 25. So 2 times 8, 3 times 8, minus 24. So you get x minus 5 by 4 the whole square is equal to 1 by 16. Is equal to 1 by 16. Right? Now I will write the continuation here. Continuation of this here. Fine. So I am writing the same step. X minus 5 by 4 the whole square equal to 1 by 16. I have written the same step here. So which means x minus 5 by 4 will be equal to the square. If it goes this side, it will become square root. I should put plus or minus square root of 1 by 16. The square goes this side, it will become, right? Whenever you have like x square equal to a, you will put x is equal to plus or minus root of a. You have to always write plus or minus. So I have seen students writing like this. If x is equal to a square, they will put x is equal to root a. You have to put x is equal to plus or minus root a, not just root a. So plus or minus root of 1 by 16. So x minus 5 by 4 equal to plus or minus root of 1 by 16 is what? Root of 1 is 1, root of 16 is 4. Square root of 16 is 4. So now we have got x minus 5 by 4 equal to plus or minus 1 by 4. So which means now here it will become two cases. Either x minus 5 by 4 is equal to plus 1 by 4. I am taking the plus sign first. Or x minus 5 by 4. X minus 5 by 4 equal to minus 1 by 4. Right? X minus 5 by 4 is either equal to plus 1 by 4 or x minus 5 by 4 equal to minus 1 by 4. So here I am separating the plus 1 by 4 and minus 1 by 4 as two cases. Here it is plus or minus, which means plus. If it is plus 1 by 4, what happens? If it is minus 1 by 4, what happens? Now x will become what? X is equal to, in this case, 1 by 4. This minus 4 goes that side, will become plus 5 by 4. Right? That gives you x is equal to 6 by 4. 6 by 4 means 3 by 2. 6 by 4 is 3 by 2. So we have got the value of x. Now again here, so x is equal to minus 1 by 4. This minus 5 by 4 goes here, it will become plus 5 by 4. You will get x is equal to minus 1 plus 5 by 4. Minus 1 plus 5 by 4, that will become 4 by 4. Which means x is equal to 1. Right? So our answers are, the roots are the solution, right? So the roots are 3 by 2, 3 by 2 and 1. 3 by 2 and 1. Clear? So this is how we apply the method of, so the same answer if you compare with example 3, where we solved and found the value of the roots using the factorization method, we got the same value, 3 by 2 and 1. Here we have done the same thing using method of completing squares. Method of completing the squares. Clear? This is how we do. Fine. So we'll do one more problem. Fine. Let's go to example 8. So I'll do example 8. Erasing this. If you can pause the video and take the notes. Fine. So example 8. We have to solve again example 8. Find the roots of the equation 5x square minus 6x minus 12. I am in the next page, which is page number 81. After example 7, we are doing example 8. Find the roots of the equation by the method of completing the squares. 5x square minus 6x minus 2. 5x square minus 6x minus 2 equal to 0. We have to solve this and find the value of find the roots, which means we are going to find the value of x by the method of completing squares. By the method of completing squares. Now, as I told you, for the method of completing squares, the first step is we have to make sure that the coefficient of x square is 5. 1. Here it is 5. We have to make sure that the coefficient of x square is 1. That is the first step. But here it is 5. So, which means we should make this 5x square to just x square. The coefficient of x square should become 1. That is the first step in solving the quadratic equation by the method of completing square. So how do I make it as 1? 5 is there. So we have to divide throughout by 5. In the earlier problem we divided throughout by 2. Here we will divide throughout by 5. Divided by 5. Then what do we get? 5x square by 5 minus 6x by 5 minus 2 by 5 equal to 0 by 5. Then 5x square by 5 it will get cancelled. X square minus 6 by 5x or 6x by 5, whatever you can write. Minus 2 by 5 equal to 0 by 5 is 0. Now we have got, now the quotient of x square has become 1. So that is the first step. We have to make the quotient of x square by we have to make the quotient of x square as 1. So which means whatever the coefficient you have, divide by each term by that coefficient, so that the coefficient of x square becomes 1. So the first step is done. Now we should compare this with either of these. Now this is like a square minus a square minus. So a square minus means it is in this. We have to take this form. So it will mostly become a minus b. So we have to concentrate on this. Now compare this. So this is a square minus 2ab. This is a square and 2ab. So now comparing this, my a square becomes what? My a square is equal to x square. My a square is, so this is like a square. So a square is equal to x square. So I'll write a square equal to x square, which means a equal to x. Then 2ab. My 2ab, this 2ab will become like this. This is my 2ab. So my 2ab will become what? 6 by 5x. Right? So this was for previous problem. I'm erasing this. So a square is x square. So that, which means my a is x. When a is x, my a square becomes x square. So we have got a. Now we should find b. For that, take this. This is 2ab equal to 6 by 5x. So 2ab equal to 6 by 5x. Which means 2, a is what? 2 into a is what? X into b. B we don't know. B we have to find. B is b. Keep b as b. A we have substituted as x. We have to find b. So b equal to 6 by 5x. Then this b will be equal to 6x by 5. This can be done as 6x by 5 also. Then 2x will go down. This 2x it is here, it will go to the denominator. So already the denominator we have 5. This 2x also will go to the denominator into 2x. Now xx will get cancelled. Then 2 and 6 will go 3 times. Your b will become 3 by 5. So we have found 3. We have found b. What is b? B is 3 by 5. Now we have got a, we have got b. Now we will write this as a square. A is what? X. A square, which means x square, minus 2 into a. A is x into b. B is what? 3 by 5. We are writing this in the form of 2ab. Now if you multiply this, what is 2 into x into 3 by 5? You will get 6 by 5. 2 3s are 6. This is 5, this is x. So you will get 6 by 5x. So this is written like this. This is written like this. This we will write it in the end. But once you got a square and minus 2ab, you have got these two terms. But b square is not there, which means we should add b square and subtract b square always. because b square term is not there. So we should add b. I need b square, but b square is not there. So which means I cannot just only add b square. I have to subtract the b square also, because the same equation should be intact. There should not be any change in the equation. So which means I'm going to add b square, which means plus b square. B is what? 3 by 5. So I should add b square and immediately I have to subtract the b square. Minus, so whatever you are putting plus 3 by 5 the whole square, you have to immediately put minus 3 by 5 the whole square. Then this last minus 2 by 5. This one I am writing in the end equal to 0. Now if you try to simplify this, you will go back to this, because this x square is x square. Minus 2 into x into 3 by 5 is minus 6 by 5x. Then this is plus 3 by 5 minus 3 by 5, they will get cancelled. This is basically 0. So this will go, you will get minus 2 by 5. So same thing you will get back this. So which means this entire expression I am writing it in the form of a square minus 2ab plus b square form. I am trying to bring that form here. Clear everyone? So that's why it's called as method of completing the squares. We are completing this. We want to make this as a square of something. This term itself, we want to make it as a square of something. Clear? So always we will add the b square. So once you write it as a square minus 2ab, immediately you will add b square and separate b square immediately. Then write this minus 2 by 5 in the end. Now what is the value of these three terms? This looks like what now? A square minus 2ab plus b square. What is a square minus 2ab plus b square? Is a minus b the whole square. What is a here? A is x. Right? From these three terms. Okay? And don't think this as divided side. Okay. I'll erase this. So these three terms in the form of a square minus 2ab plus b square. So that can be written as a minus b the whole square. A is x minus b. B is 3 by 5. This is your b. So that's why a square minus 2ab plus this the whole square. So these three terms are written like this. After that what we have? Minus 3 square is 9 by 5 square is 25. Then this is minus 2 by 5 equal to 0. Clear? So these three terms are, this is in the form of a square minus 2ab plus b square. So we have written it as a minus b the whole square. The remaining is this term and this term, they equal to 0. Clear? Now x minus 3 by 5 the whole square, we have to move the numbers to the other side. Minus 9 by 25 goes to the other side, it will become plus 9 by 25. Minus 2 by 5 goes here, it will become plus 2 by 5. Fine. Now what do? We will have to add them, right? Equal to. So what do we get? If you try to add them. Now add these two. So which means 25 is the denominator. 9 plus 5 2s are 10. 5 5s are 5. 25 into 5. 2 5s are 10. So you will get 19 by 25. Here you will have x minus 3 by 5 the whole square. So x minus 3 by 5 the whole square equal to 19 by 25. Right? Now I am going to continuation of this here. So which means I am writing the same step, x minus 3 by 5 the whole square, or I can write one more step here. So this will become x minus 3 by 5 equal to plus or minus square root of 19 by 25. So the square goes this side, then it will become square root and you should put plus or minus always. So which means x minus 3 by 5 is equal to plus or minus root of 19 by root of 25. Root 19 is root 19 plus or minus root 19 by root of 25 is what? 5. Square root of 25 is 5. So it will become plus or minus root 19 by 5. There won't be any square root here because square root of 25 is 5. Now we will have two cases, which means x minus 3 by 5 equal to plus or minus. So I should take the plus case. X minus 3 by 5 is plus 19 by root 19 by 5 plus case, or x minus 3 by 5 will become minus equal to minus root 19 by 5. We have to take two cases. A plus what happens, minus what happens, because this is plus or minus. So this will be getting split into 2. Fine. So now what do we get? So x equal to, this is root 19 by 5. This is minus 3 by 5 goes here, it will become plus 3 by 5. Fine. So now x is equal to, now 5 is the denominator, common 5. Then this will become root 19 plus 3. I can write this as x is equal to, generally we write the number first. X plus, sorry, 3 plus root 19 by 5. This is the value of x. We generally write the number 3 first, then I am writing 19. So x is equal to what? 3 plus root 19 by 5. So here what happens? If it is minus root 19 by 5, what is my x? My x becomes minus root 19 by 5. Minus 3 by 5 goes to the other side, it will become plus 3 by 5. Now I will get x is equal to minus root 19 plus 3 whole divided by 5. Because denominator is same, I am adding. So generally we will write the number first, which means x is equal to, we will write the number 3 first, then minus root 19 by 5. So the answer is x is 3 plus root 19 by 5 or x is 3 minus root 19 by 5. So these are the two roots of this quadratic equation, which is this. See, it is not like you can solve all the quadratic equation by factorization method. We cannot solve all the, so there are many quadratic equations which you cannot factorize. Like straightforward, like m equal to something, a equal to, so that factorization will not be so straightforward for many of the quadratic equations. So we go for other methods like method of completing squares, or we have one more method which is called as quadratic formula, which we'll study in the next section. So example 8 is, this is how we do. Clear? So this is how we find the roots of the given quadratic equation by the method of completing squares. So we'll do the next problem, which is example 9 in page number 82. So we'll do example 9. So that is also by the method of completing squares. We are going to solve 4x square plus 3x plus 5. We have to solve this by method of completing square. Method of completing the squares. We have to solve this by the method of completing squares. We have to solve this. Now what is the first step for the method of completing squares? We have to make the coefficient of x square as 1. That is the first step. We have to make the coefficient of x square as 1. So how do I make the coefficient of x square as 1? Coefficient of x square is 4. We should make it as 1, means we should divide by 4 throughout. So I'll write 4x square by 4 plus 3x by 4 plus 5 by 4 equal to 0 by 4. That's the first step. Now 4 will get cancelled. You'll get x square plus 3x by 4 plus 5 by 4 equal to 0, because 0 by 4 is 0. Now we should compare this with, now it is like what? This is like a square plus 2ab, these two terms. Now compare this with a square plus 2ab. A square plus 2ab. So if you compare that, then what is our a? Your a square is x square. So my a square is x square. So therefore my a will be equal to what? So a equal to x. Therefore my a will become x. Now this is your 2ab. Your 2ab plus 2ab, this one. So this 2ab, don't go here, because this is plus. So we have to take this one. Plus, so 2ab is equal to 3 by 4. So my 2ab equal to 3 by 4x. My 2ab is what? 3 by 4x. Now we should find the value of b. What is a? A is x. Substitute a is x here. So 2 into a is x into b equal to 3 by 4, 3x by 4. Now we should find the value of b. B will be equal to 3x by this 4. Then 2x will come down. It will go to the 4. Right? 2x will come down. So which means it is into 2x. It will come down. Now x will get cancelled. We will get b as equal to 3 by 4 into 2, 3 by 8. You have got the b now. You got the b. Now once we find a and b, we should write this as a square, which is means x square, plus this should be plus 2ab. So 2 into a is x, into b is 3 by 8. Now if you multiply all the 3, what do you get? 2 into x into 3 by 8 means 2 and 8 will get cancelled. You get 3 by 4x. This will get back this. The same expression we are writing in the form of 2ab. That's why we are finding b. Only when we find b, we can write as 2 into a into b. Now we got x square, which means a square plus 2ab. We need plus b square. But we don't have, which means we should add b square and subtract b square immediately. So add b square. B is 3 by 8. So adding b square. Then subtract b square. B is 3 by 8. So I am adding b square, subtracting b square. Then we should write this 5 by 4 plus 5 by 4 equal to 0. This 5 by 4 comes. It's the same expression. We have written it in such a way that the first 3 terms gives me a plus b the whole square. And how we know it should be a plus b the whole square and not a minus b? Because this is plus. If this was minus, then we would go to this. Now again take these 3 terms. This looks like a square plus 2ab plus b square. So it can be written as a plus b the whole square. A is x, b is 3 by 8. This these 3 terms. Then after that we have what? Minus 3 square is 9 by 8 square is 64. Plus 5 by 4 equal to 0. Right? After that I am writing, so these 3 terms have become like a plus b the whole square. After that I have minus 3 square is 9, 8 square is 64 plus 5 by 4 equal to 0. Fine. So which means now if I simplify this, I'll get x by 3 whole square equal to x plus 3 by 8 whole square equal to, this numbers will go to the other side, RHS, right hand side. So it will become plus 9 by 64 because minus 9 will go here, it will become plus 9. And plus 5 by 4, if it goes here, it will become minus 5 by 4. Now we should add the fractions. 64 is the LCM. So 9 minus, this is 4 into 16 is 64, so 5 into 16, which is 80. And this will be x plus 3 by 8 the whole square. So which means x plus 3 by 8 the whole square is equal to minus 71 by 64. Because 9 minus 81 is minus 71 by 64. Now what we have observed here is, now there is a problem here. There is some problem here. What is the problem? I am squaring some number and I am getting negative value. Whatever real numbers, whatever numbers you know at this point in time, I am using the word real numbers cautiously because we have something called complex numbers which you will study in the 11th standard, wherein we will study about the complex number and all that. So here till now we will study only the square number. The square of a real number cannot be negative. You cannot find a number, a real number, when you square that it will give negative. No, because minus 2 if I square I'll get 2. So square of any real number will be either 0 or positive. It can never be negative. It can never be negative. You cannot get the negative value. So whenever you do this, the earlier problem and all we are getting only positive value here. In the earlier 2 problems. But the moment you see square of something, it's a number. Ultimately it's a number. When I put some value for x, it's a number. So square of a number cannot be negative. Square of a real number cannot be negative. So whenever you get a square, left hand side a square of something, right hand side you get the negative, you have to stop here and say that there is no solution. So how do we proceed here? We will say square of, so we will say we see that square of a real number, we see that square of a real number is negative, which is not possible. Which is not possible. Square of a number cannot be negative. So we see that the square of a real number is negative, which is not possible. So therefore, the quadratic equation does not have a solution. Quadratic equation, the given quadratic equation does not have roots. In particular, we call it as real roots, because we have when you go to the complex numbers, then we have something called imaginary roots and all that. But the quadratic equation does not have roots or does not have a solution. Or we can also say the quadratic equation does not have, instead of roots you can say solution. Roots or / solutions. That's all. Solutions. Then we should solve the problem here. When you try to do method of completing squares and you get into a situation where the left hand side is square of something but the right hand side is negative, that is not possible. Which is never possible because square of a real number cannot be negative. It can be 0 or positive. It cannot be negative. Square of any number you take. If I say minus 3, what is the square of minus 3? Plus 9. You take minus 5. What is the square of minus 5? Plus 25. So square of any real number cannot be negative. It can be 0. If you take 0 as a number, 0 square is 0. You can get 0 or positive value. You can never get negative value when you square a number. So therefore, that is why we are saying this quadratic equation does not have real roots. We say roots, which means real roots. So we'll stop then we will end the problem. This is the end of the problem. We can't find x. We can't proceed after this. We have to stop here and say we cannot find x because it does not have a solution. Fine. So we'll stop here. So this completes example 9. Watch my next video for the continuation of the next example. Thank you for watching the video. See you in the next video. Thank you.